Some equations we're going to see are more than one step. So today we're going to look at two-step equations. And just a quick reminder, we have inverse operations that we use or opposite operations that we use to isolate the variable. Our goal is always to isolate the variable or the letter. So if we see addition, to undo that we use subtraction. If we see multiplication, to undo that we use division. And the opposite is true. To undo division, multiplication. To undo subtraction, addition. So when we have an equation with more than one step needed to solve it, the first thing we're going to do, it's kind of like the opposite of our order of operations. The first thing we're going to do is we're going to undo our addition and subtraction. So basically we're going to get rid of the thing that does not have the variable attached to it. Then the last thing we're going to do to isolate that variable is get rid of the multiplication or division. So looking at a couple examples here, again, I'm just going to draw a line down there just to keep my left side and right side straight. If that doesn't help you, don't feel the need to do it. We have 4x minus 20 equals negative 8. My ultimate goal is to isolate this x. Right now it's being multiplied by 4 and it's being subtracted by 20. So we're going to get rid of this minus 20 first. We undo subtraction with addition, and we always have to do the same thing to both sides. Negative 20 plus 20 cancels, and I'm left with 4x. We just bring down what we haven't done anything with yet, equals 28. Okay, now we're left with just a one-step equation. We see that there's multiplication happening to our x. It's being multiplied by 4. So to undo that, we divide both sides by 4. 4 divided by 4 just gives me 1x, or x. 28 divided by 4 equals 7. So we use inverse operations until our variable is isolated. Example 54, we have 5x plus 7 equals 7. Again, we undo our addition and subtraction first. I'm going to subtract 7. 7 minus 7 is 0, so I'm left with 5x, and on this right side we also have 7 minus 7. I'm going to go ahead and write a 0 there so that we can keep solving. I have 5 times x equals 0, so I divide by 5 to isolate my variable. 0 divided by anything just gives us 0, so x equals 0. Okay, careful on example number 55. We have 4 minus 2x equals 10. Careful the order that this is written in. We have to get rid of that positive 4 first. So to get rid of that positive 4, we're going to use minus 4. 4 minus 4 is 0. And I'm going to bring down that negative 2x. Be careful that that negative stays with that 2. The sign in front of the term stays with that term. 10 minus 4 on the right side gives us 6. Last step is always our multiplication and division. In this case, to isolate the letter, we need to divide by negative 2. And I'm left with x equals negative 3. Okay, example number 56, we have 8 minus x equals 2. Notice there's not a number written in front of our x. We just have a negative sign. So we know that that has a value of negative 1. I'm going to go ahead and write that in there so we don't forget when we're solving. I need to get rid of the number without the variable first. It's a positive 8, so we subtract 8, and I get negative 1x equals negative 6. Okay, my x is almost isolated, but there's a negative 1 being multiplied by it. So we're going to divide by negative 1, divide by negative 1. We get x equals negative 6 divided by negative 1, gives me positive 6. Okay, a few more. Solve the same way. We have negative 3x plus 7 equals negative 8. Our goal is to isolate the x. The first thing I'm going to do is minus 7, and we get negative 3x equals negative 15. Divide by negative 3. We end up with x equals negative 15 divided by negative 3, positive 5. Okay, on the middle one, negative 2 plus 9x equals 7. The negative 2 is what we need to remove first. To remove that negative 2, we're going to add 2. What we do to one side, we do to the other. Negative 2 plus 2 is 0, and I'm left with 9x equals 9. To solve for x, we divide by 9. and we get x equals 1. And then our last step here, and actually the only one in these examples where we see my x being divided by a number. So don't forget the inverse of division. We're going to use multiplication in just a minute. We still want to remove that subtraction first. We use addition to do that. Negative 4 plus 4 gives me 0. And I'm left with x divided by 5 on the right side equals positive 1 on the left side. Okay, my x is being divided by 5, so to undo that division, we multiply by 5. Multiplication and division cancel their inverses, and I'm left with x equals 5 times 1, or x equals 5.